All right, guys, let's take a look at Unit 8, Lesson 2.
Students will be able to solve
Area problems with parallelograms. Parallelograms, okay? That's what the shape is in front of you. Let's look at the first question. Lewis's teacher asked him to find the area of the parallelogram pictured below. Okay, I think we all can see that. So make sure we're on the same accord. This is the one we want to find an area for. It almost looks like a rectangle just slanted to the side. That's my first observation. Well, let's look at the rest. He wasn't sure what the area formula was for parallelograms. So he cut a right triangle off of the left side of the parallelogram and moved the right triangle to the other side of the parallelogram, forming a rectangle. So it looks like he simply cut off a piece, literally, and put that piece right here. And he was able to create a rectangle. And right here, we can see his steps, kind of what I just did. First, he cut it off, then he moved it, and he was able to find the area like that. So it says, assuming that what Lewis did is okay, how should he find the area of the parallelogram? Well, now that it's a rectangle, can't we just say that the area will be its length times its width? And by substitution, that would be 4 times 6, which would just give us 24 square units. I'm sure we all agree, but there may be some confusion because parallelograms, they don't start off as rectangles, and all of us don't have access to scissors to cut every sheet of paper to make it look like a rectangle. But the idea is what we want you to take away. It seems like we are able to use something very similar as a formula for finding the area of a rectangle to the formula for finding the area of a parallelogram. Let's go ahead and explore this, guys. On the next page. Now, the first thing I'm going to write down is the conjecture, just so you all know what's going on. So I'm going to say this. The area of a parallelogram. I don't expect you to spell parallelogram wrong because it's written for you and it's in the questions. Parallelogram is measured the same way as the area of the rectangle. Okay, let's go ahead and test this out. Let's look at number 1 in the test conjecture. It says, what is the area of the parallelogram below? So typically, a person can go ahead and cut this little piece out, and we can place it over here. We could turn this into a rectangle. And the only thing that we would need is whatever that height is, which is a 7, and whatever this base is, which is 8. Which goes to show that this number right here, we don't need it, guys. There's nothing we're going to use that number for, so I'm going to go ahead and circle it and put an arrow. I'm going to put not needed. It's just there because once you get a little bit more advanced in geometry, then you'll see what we can use that number for. But as of right now, you have to recognize that that number is just there, okay? So try not to use it. So I'm going to leave you a note real quick. If I cut off the triangle, and place it on the other side, I can make a rectangle. Now, some of you may have access to paper to where you can do this right now, But if you can't, just go ahead and imagine it. Imagine just taking this little triangle right here and placing it right there. Just imagine it. And it's just gonna look like a rectangle. Now, a parallelogram still isn't a rectangle for some specific reasons that we'll discuss maybe later. So we can't use the exact formula. I think the process will be the same, but the formula will simply look different. We know that the area of a rectangle is written as its length times its width. Or let me go ahead and take out the X. I'm just gonna put LW. Similarly, the area of a parallelogram is something times something. We're just not gonna call it its length and its width. We're gonna call it its base and its height, okay? Its base and its height. Normally we think of a base as something that's on the bottom, something that supports it, okay? So I'm gonna say that the base is 8. And the height of something, we're gonna say that is 7, only because that's how tall it is. Now, some of you may be thinking like, Mr. Evans Parker, how come 7.8 isn't the height? When you go to the doctor and they take your height, are they measuring you while you're leaning to the side? They are not. They're measuring you standing straight up. So the line that is from the base to the top of the figure is your height, okay? We can't be measured standing sideways. We have to stand straight up. So now that we know which formula we're using for a parallelogram, not the rectangle, we're gonna figure out what's given to us. So the area isn't given because it's being asked for. Is the base given? Yes, it is. The base is 8. Is the height given? Yes, it is. The height is 7. I'm just gonna put a little rectangle around this because it's kind of what we need. Now I can use my substitution to figure out what this area actually is. So A is equal to, my base is 8. My height is 7. So A is equal to 56 centimeters squared. Did our conjecture prove to be true? Yes, because if I simply put this other part here and I measure it as the length times its width, it'll still be 7 times 8, which is 56. Okay, let's go ahead and check number 2. To reboard a rug in the shape of a parallelogram. Cool, so we know what formula we're going to use. Shown below. How many square meters of space will the rug take up on his floor? Now, some of you may think that there is an actual triangle here. This is not an actual triangle. If you see those dotted lines, we simply drew those dotted lines so we could figure out the height of this parallelogram, okay? So let's go ahead and figure out what we need to do. We need to write down what's given, always. And trust me, if you put it in the form that I'm putting it, you're not gonna have trouble with this packet. So the area, we don't know yet. Now, what formula are we referring to? I'm gonna go ahead and write it down. BH. Why is it BH? Because this is a parallelogram, not a rectangle, okay? So the base is whatever the bottom of it is. So it's right here as 4 1/3 meters. 4 1/3. The height is, now remember, from here to here isn't the height because it's slanted. 3 1/2 is the height. Okay? 3 1/2 meters. This number, not needed. Why? Because they gave us the space from the actual figure to the height that we needed. Okay, so I'm gonna go ahead and cut that off. Now I can go ahead and use my substitution. Okay, so A is equal to, what's our base? 4 1/3. So I'm just gonna write that in. And what's our height? 3 1/2. Now, there are a bunch of ways you can figure this out. Some of you may use decimals. Some of you may use fractions. I'm going to tell you that it doesn't matter. You just have to be able to get to the correct answer. Unless they actually asked us to make sure it's in decimal form or fractions, then you use whatever gets you to the answer. So I'm going to stick with fractions at this point. I'm going to convert my mixed number into an improper fraction. As you can see, I don't need to do any side work yet, but when I do, I'll have space for it. Is it something I can do in my head? Maybe, maybe not. I can definitely do the denominator in my head, but 13 times 7, you might want to do some side work for that. I'm going to say that the result is 91. So I don't want you to leave your result as an improper fraction. You can either convert this to a mixed number or a decimal. So I'm going to say that this mixed number is going to be 15 and 1/6 meters squared. Okay, and any of you should be able to change that into a decimal if that's what you chose to use. As you can see, the fraction form may be slightly simpler, slightly. So let's go ahead and look at what we did. It says to reboard a rug in the shape of a parallelogram. Cool. How many square meters of space will the rug take up on his floor? That's what the area is, how much space it takes up. And we notice that this triangle drawn on the side with the dotted lines isn't really there. It's just used to help us find other measurements, okay? The solid line, which is the parallelogram, is the actual figure. The base is the bottom. So it's the 4 1/3, and the height is 3 1/2. Remember, the height isn't measured at a slant. It isn't measured at a curve. It's measured from its base to where it goes up top. And that's it. Okay, guys, I'm going to reread the conjecture one more time. The area of a parallelogram is measured the same way as the area of a rectangle. The process will be: recognize your dimensions, draw your table of what you're given, use the correct formula, then substitute to answer the question.